Hello and welcome to the Wolfram Virtual Conference. I'm glad to see so many of you have joined us here today to see how you can innovate and compute more every day with the Wolfram technology stack. Now, a year ago, Stephen Wolfram introduced the Wolfram Language, and in that time, a robust ecosystem has started to grow up around it. The Wolfram Language is a symbolic language with knowledge-based computation at its core, and is the underlying language behind most of the Wolfram technologies. Last month at the Wolfram Technology Conference, we shared some of the progress and latest developments of our technology. And we've got some of the speakers from that back here today to talk about what they've been working on, and we have plenty more to share across the two tracks. Track 1 today will focus on applications of the Wolfram technology, and Track 2 will highlight the advances of the technology. You can select presentations from the navigation bar anytime you wish to return to the presentation schedule, or if you want to switch to the other track. If you remain here in the track you've selected, you'll automatically enter the next talk on the schedule. Throughout this conference, Wolfram experts will be on hand to answer your questions, and each of the speakers will stay for a Q&A session right after their talk. It's fine to submit your questions at any time. There are two major branches of new technology that have been dominating our focus this year. The first is the release of our initial cloud products, the Wolfram Programming Cloud and Mathematica Online, and the other is a new version of our flagship product, Mathematica 10. Let's start by looking at the cloud products, and we'll start with Mathematica Online, which is a natural progression from Mathematica on the desktop. And if we take a look at that, we can see something that looks very familiar to any Mathematica user. It's a notebook interface where I can type Mathematica input and see results. The difference here is that not only are we seeing the content in a web browser, but that it is being rendered entirely in the browser. I'm not using the CDF player plugin at all. It's just HTML and JavaScript, making it accessible to essentially any modern browser. In fact, there's nothing installed locally for the computation either. That is done on the Mathematica Online servers. Together with a significant cloud storage allowance, you can access, edit, and compute with your files from anywhere with zero setup. Nearly all the features of Mathematica for the desktop are available in Mathematica Online, including the popular interface building manipulate command. In fact, what you see here doesn't just look like a Mathematica computable document, it is one. That means that files created in the cloud can be downloaded to the desktop for offline work, or sent back to the cloud for remote availability, or collaboration with others, either manually or under program control. It's a truly hybrid cloud desktop solution. Now, our other cloud product is the Wolfram Programming Cloud, and while it uses the same underlying technology, it's got a completely different purpose. Mathematica Online is intended for personal development and collaboration with others, but the Wolfram Programming Cloud is there to deploy your work to a mass audience. Let's start with the simplest deployment, a manipulate. Let's take the one I just created. And now I can use a new deployment command from Mathematica, and it works from the desktop just as well as from the cloud. And I've just shared this for anyone in the world to use. If I make a quick short URL, then you should be able to try it out right now while I talk about the other main form of deployment. The manipulate interface is meant for humans, and we also have a nice new web form object which is similar. But sometimes you want to deploy computational services for a computer instead, and we have new capabilities for that too. I can describe a RESTful web service using this new API function command. This one is really simple. It's just going to do a simple numerical computation, but it could do anything written in the Wolfram language. And I can also control whether the result is returned as plain text or in some richer format such as JSON or XML. I now deploy it just as I did before, and this new URL that is created can be called from another application right away. There's still work to do to make the correct call from that other application, but we've helped with that step too. Since the API function is a full symbolic representation of the arguments and return types, it can be used to generate a snippet of code to paste into my application. Lots of languages are supported, such as C, Python, and Visual Basic, and the same function can be used to generate HTML frames for embedding the manipulate that we saw earlier into web pages. These two tools free the Wolfram language from the confines of the desktop. You can develop and collaborate using cloud-based files, using Mathematica Online, and then instantly deploy to websites or web services using the Wolfram Programming Cloud. Now, other new deployments include a new automated template-based report generation system, which of course is compatible with instant deployment through the Wolfram Programming Cloud. And the Wolfram language can now run on a new generation of system-on-a-chip platforms such as the Raspberry Pi, allowing you to deploy to devices. Now, of course, Mathematica has always been the major implementation of the Wolfram language. And the new version of Mathematica, Mathematica 10, represents a huge leap forward. There's over 700 new functions. And at the same time, we've made it easier to use than ever before. With its huge range of statistical capabilities and high-level pattern matching language, Mathematica has long been used as a powerful tool for data science. But Mathematica 10 extends those capabilities by adding new efficient and convenient ways to quickly process data using named references. Operations like dataset joining, data selection, and aggregation are now much simpler, and a new automated semantic import standardizes data and connects it to Wolfram Alpha's knowledge base. New machine learning capabilities provide fresh insight from your data by allowing predictions to be made without you needing to develop a model. Training a classifier is fully automated, with Mathematica choosing the appropriate algorithm and automatically handling mixed data types and missing values. Just train and use. And of course, it isn't limited to numerical data. Classify images or sounds or text just as easily. Support for images and sounds have also been extended in other ways too. New image processing capabilities provide more image segmentation options and content recognition. Nearly all of Mathematica's 2D image filters, morphological tools, and content analysis have been extended to support 3D images to make medical imaging or industrial quality control development easier than ever. Many other key domains of computation have also been extended. Graph computations have been extended to support mixed multigraphs, and new path and tour finding algorithms added to make social network analysis or network optimization in transport or communications easier than ever. Signal processing has been extended with new peak, baseline, and envelope detection, and new calculus includes symbolic solutions for event-driven and delayed differential equations, and control theory functions now support affine and nonlinear control models. But perhaps more exciting are the new domains which Mathematica 10 has now grown to cover. A whole new framework for geo-visualization now allows geo-information to be displayed on regional, national, or street level. Like all Mathematica graphics, they're fully customizable, allowing you to control colors, textures, and annotations. And all these computations are geo-aware, allowing you to specify them by place name, and automating the calculation of geo-curves and geo-circles on any map projection from any geodesic coordinate system. If you have geodata to display, Mathematica is now the place to put it. A new geometry framework allows you to calculate properties such as distances, areas, volumes, and centers of geometric objects. Like almost everything in Mathematica, it supports exact and high-precision numbers and symbolic values. With a full set of primitives and tools for combining them, any shape can be described in any number of dimensions. And with a full 2D and 3D mesh generation system, discrete regions are supported too. This makes it easy to use messy, complex, real-world shapes and objects just as easy as idealized mathematical ones. And these regions are not just for geometry. They can be used to control all kinds of calculations too. We can plot over regions, solve over regions, optimize over regions. And Mathematica now includes a complete finite element solver to allow PDEs to be solved over 2D and 3D regions. Whether you're calculating waves over a geometric space, or heat propagation or stresses over real physical objects, or just solving a high school geometry question, Mathematica provides the answer. A new time series framework makes it easier to merge, transform, and select from time series data. And using new tools like time series model fit, it integrates tightly with the existing random processes capabilities to predict or simulate from historical data. Like other areas, the random processes have also been extended too, with new Arch and Garch processes and support for hidden Markov chains. Of course, the Wolfram language is not just about controlling broad and powerful computation. It's also a development platform for building computation-driven applications and tools. Lots of new convenience functions and developer tools like unit testing make getting work done in the Wolfram language quicker than ever. And the working environment for writing code has been enhanced, with new auto-completions for option values and strings, automatic interfaces for finding paths, colors, fonts, and styles, and improved undo and redo capabilities. It's never been easier to write code in Mathematica, and the Wolfram language has never been more expressive. But more important still are the new, easier ways to instantly deploy Mathematica-based solutions and to share them with others. I've talked already about the cloud deployment of apps and documents and APIs through the Wolfram Programming Cloud, but there's another important kind of deployment, and that is directly onto physical devices. The new generation of system-on-a-chip hardware makes it possible to run a full Mathematica on an autonomous device. Available now is a version of Mathematica for Raspberry Pi, and other platforms are in development. With new support for reading sensors and controlling devices, the Internet of Things just became the Internet of Smart Things. So, with richer data handling, computation, language, deployments, You can see we've made a lot of valuable functionality available to you, and I hope you'll stick around to learn more about it. After I take some questions from this presentation, Track 1 will feature Mathematica Online with Michael Morrison, and Track 2, Machine Learning with Etienne Bernard. If you're already in the right track, just stay put, and their presentations will start right after this Q&A session. So bear with me as I switch over into the chat area, where I hope you'll already have some questions waiting for me. Just type in your questions, and I'll try and answer as many as I can before it's time for the next session.